Oh no, my beard is gone. Hello and welcome to another Solana tutorial. Today we're gonna talk about create account with seeds. As promised in one of the previous videos, I want to do a deep dive on that and really understand what that does. Because we kinda understand what create account does, but we wanna understand what create account with seed does and what the advantages of using that are. So join me on this deep dive on the system program create account with seeds instruction. I love to learn about Solana, and that's what we're here for. I'm excited about this one. I wanted to look into this for a longer time now, and I finally get to do it on the day after my birthday, because no working on my birthday. Yeah, let's do it. I'm so excited. Let's go. I'm not gonna keep that excitement, don't worry, but hopefully this is going to be a short video where we just go through it all and then we understand it and then we can use it. Oh yeah, looking forward to that. So let me hide down here and get myself a file. And the first thing we'll need, Solana web3.js, because that has all the helper functions. And here we have the system program, which will have the create account with seeds. That's what we want to have a look at today. But before we have a look at this, we're gonna have a look at this, or at least one more time go over what create account does, just that we're all on the same page on that, and that will help us understand the difference between those two. Because essentially, create account with seeds does the same thing as create account, just a bit differently. So we need to understand what create account does in order to understand what create account with seeds does. So understanding create account first. This creates us a transaction instruction, and it takes the following parameters. And this stuff is always where I got curious as well. Well, what are the other things? I always just did from pubkey. So I don't know, I have a pubkey that funds it, like my address. Let's do fun. Fun is fun. Funds, the funder. So we basically just load that key pair, and then we can say the funder funds it. So from pubkey, funder. Okay, then we need to say which account do we create, and that's usually a new key pair. So just a new account. Should we call it new account? Let's call it new account, such that it's clear this account is just being created. And then what create account does is it adds Lampert to the account, allocates bytes, and then assigns it to a program. All of those at the same time. Plus checks that the account does not exist before. I could also do the same with transferring Lamperts there, allocating and assigning to a new program. That would have the same effect. But I don't know in which order I need to do it exactly, because there are some tricks to that. We can also have a look at that. But anyway, so we need to say how many Lamperts do I put there. Usually that's exactly what I need for rent exemption. So probably it would make sense to start with the space. So how many bytes do we want to allocate? We're just creating a demo account. This should usually be the size of the data that we actually need. I could now either calculate that manually or request from RPC how much rent do I need for that, because that eventually will change. It will not be static as it is now. So let's do it dynamically and read, but for that we need a connection and an async function, fine. And then we can say connection, get minimum balance for rent exemption, and then we just take the space. So don't have a good name for that. But anyway, so that's the... Could also just call it space, but I want to make it more clear to you what that actually means. So how many bytes does that account have? Additionally to the metadata fields. So that's just actually the account data bytes. Yep, and then we will need to await this. Gives me a promise of a number, and the number we put in as Lamperts. And then we need the program ID of the program that we assign to. So what program are we going to assign to? Prox. It's a hoax. Let's pretend. And like that, we should get the instruction. And then, as usual, we put that in a transaction and send it or whatever. Get the instruction, send and confirm a transaction, because that will also put in the block hash and sign with the signer. My funder. Cool. Print me the signature. And let's try that. Maybe I should get an airdrop first, actually. because otherwise we get the classic, we don't have enough Sol. Oh, actually, no, we get a signature verification failed. That's true. That's true. We're not signing for this one. Right. Even before it gets sent, even before it can check if it can send it, it's checking that all the signatures are present, and not all the signatures are present. Why? Because the create account requires the new account to sign, because otherwise the system program will not allow that account to be created. Only the person holding the private key for this will be able to create that account. And by holding the private key, it could of course also be a PDA, so it could also be a program doing a CPI and providing the seeds. But the signer flag for this account needs to be set. That's what I'm saying. And if it's this account, like this, directly with the system program, then it expects this guy to sign. So that's why it's now complaining here that 9Z, that was my random key pair. So I also need to put that new account here as a signer. If I put the new account here as well, because again, that's a key pair, it can sign, then that's gonna work. Is it gonna work? No, of course not, because I ain't got some Sol. Yeah, attempt to debit an account. That's what I expected. Okay, so we gotta airdrop me 2 Sol. Yeah, we getting Sol. Wonderful. Now, try again. Okay, wait a little longer and try again. You can give it up and try again. Push that button and try again. Try again, try again. Do-do-do, do-do-do-do, do-do-do. Do-do-do-do. A signature is not wunderbar. Da-da-da-da. Da-da-da-da-da. Actually, somebody suggested to me that I use Solana.fm because they also have a good explorer. Let's see if I feel happy with this. And they also said there is a developer mode. Yes, this I definitely want to turn on. Not used to Solana FM? We got you. Legacy mode. Yeah, that's more what I'm used to. But anyway, what do we see here? Just a system program create account for this account. At least this one has a dark mode, so that's already great. We got max confirmations. Those two signed, so my pair and the random key pair both signed to create this account, because otherwise the system program won't let us create that account. Oh, that's actually quite nice. So in the data, we see the discriminator is 0. So that's the create account discriminator. Then the Lamperts, that's how many Lamperts. It got that from the get minimum rent exemption for this amount of bytes, gives us this value. So this amount of Lamperts were put onto that account, and the new owner is now the prox. Oh, so that's the pretty way. I can do JSON way. I can do raw. That explorer is actually quite cool. Maybe I'm gonna use that more often. So we got the data in hex and here in base 64. I can even put base 58. Haha, that explorer is cool. I like it. Okay, thanks for the recommendation. Maybe I want to get used to using Solana FM. Plus also they support token extensions. And they're like purple. So like, come on. Can't argue with that. Okay, anyway, back to being productive here. So that was the data. It's not actually that important. My whole point is that this account has now been created. And if we go to that account, oh, nice. It even shows me what data is in here. Haha, I like that explorer. And how many bytes? Who's the owner? The Lamperts. If it's on curve. True. So it's not a PDA. It's one where the private key exists. So the system program needed the signature created with the private key in order for that account to be created. Because the system program has control over all of the accounts that have not been allocated. So if you want to create a new account, you need to go through the system program. And the system program will only allow to do anything with accounts that you provide the signature for. Unless you're just sending Lamperts there. That it allows to all of the accounts. So it then creates the account, but keeps it assigned to the system program. So if you want to change ownership like the create account does, changes the owner to a program, then you need to sign. Yeah, cool. Okay, just as a quick exercise, I want to try doing the same thing as the create account without using the create account. So I don't do this. And instead here I add a system program allocate. Okay. Haha. Here we already see a base pubkey and a seed, because if we want to do that the same way we do create account with seeds, then we will need that. But for now, we just need the account, the space, and the program ID. So actually, I'm going to do it outside, or we do instructions and do an array. And then the account pubkey, that's basically the new pubkey from up there. So that's our new account public key. And then space and program ID, we can also copy from here. So how much space do we want to allocate and which program ID? And for that to work, because just like this, it's not going to work. Let me demonstrate. I'm going to put the instructions in here. Even if I sign with the funder and the new account, I can't just allocate, because check this out. There are no lamperts there, of course. It's a bit slow to tell me that. What? That worked? We allocated 69 bytes for this, but this has no lamperts there. So I mean, okay, it worked, but then it still is an empty account that doesn't exist. So fair enough. I mean, it worked, but it didn't work in the sense of it achieved what we wanted to do, because the account just isn't persisted because it doesn't. Okay, whatever. So for that to actually work, we gotta do a system program transfer first. And we transfer from a pubkey, my funder, to a pubkey, my new account. Lamperts, well, this thing again. So we first transfer and then we allocate, and that thing should now also work plus have the account persisted, because we transferred some funds there and then we allocate. We first transfer and then we allocate. Then that should actually stay persisted. Look, cool, stays persisted. And it is as if we would have called create account, except it stays with the system program. So owner is still the system program. So that's one difference. But we can also do that by manually assigning it. System program assign. Which account? Again, we see this nice base and seed that keeps following us around. And we will see that again later. But for now, we can ignore it and just use the program ID. We assign it to our program ID. And then look at that. There we go. That worked. And now we created an account for DHA with those three instructions: transfer, allocate, and assign. And we can look at the discriminators. Here it's 2. Here it's 8, and here it's 1. Isn't that nice? I love that. I love how it just, yeah. Anyway, but then we can look at that account, and this one is now persisted, has some data, plus is assigned to our program prox. So pretty cool, huh? I kind of like that. So basically this is the same as this. So you see why you would want to have just one instruction instead of 3. But really what that does is this plus some additional checks that the account doesn't exist before. Because here the account can already exist before. It will just accept that. Whereas here it actually checks that the account has 0 lamperts on it. That's why we have a separate create account. Because otherwise we could have just created a wrapper. But also just having one instruction is cleaner, because also instructions are limited, as we saw in the previous video, or in one of the previous videos, depending on when I upload this. Cool. So just for your mental model, it's a transfer, allocate, and assign what the create account does. Cool. So we can create accounts like this. Now we can finally get to creating accounts with seeds. Triple E, because I like it. I like it. And it's gonna work similarly, except we will not need a new key pair. Boom, get rid of that. See, there's one place where I need a semicolon in TypeScript, and that is before that. Cool, so we do the same thing, except we don't do create account, but we create account with seeds. This will have different parameters, who would have thought? But most of them are gonna be the same, so I can leave them here. I just need to add a few in addition, and that is the base pubkey, which we will discuss what that is. For now, I'll just say it's my funder's pubkey. Yeah. And then the seed, which we can also discuss what that is, but that's basically just any bytes. You know how when we create PDAs, we have seeds? That's very similar, if not the exact same. So it's just a list of bytes that we put in here. So I don't know, I buffer from... Oh, you even want a string directly here. Okay, well, I can put you a string. Seed. And one more thing, that new account pubkey now must be something special. Not only do we just not have that, but that thing now has to be a specific account. Why? Well, because it's derived with a base pubkey and seeds. How is it derived? Well, conveniently, there is another method. I just don't know where it is. Was it in public key? Yeah, so we have the create program address sync in pubkey, which is what we do to create PDAs, right? So where we put in the seeds and the program ID, that's how it derives a PDA. But then there's also the create with seed. Derive a public key from another key, a seed, a program ID. So the program ID will also serve as the owner of the public key, giving it permission to write data to the account. Yeah, as we know, program ID will serve as the owner. So we see what 3 things it takes to derive this address. Number 1, a from pubkey. And that from pubkey, not to confuse it with this from pubkey, is now actually the base pubkey, as far as I can tell. So we need to put our funder pubkey. The seed, maybe I should save it like this. See, it takes it as a string. I don't whatever. It takes it as a string. That's fine. And then the program ID. So program ID will then also serve as the owner. So we need to put in the same program ID as we put here. The same idea. No, same ID. Speaking is difficult. And like that, we will get a public key, which is now our new account. We can say our new account is this. Except here we get a promise because this is not sync. Is there a sync version of this? Nope. They never bothered to make it a sync one. So we just have to await this. Fine. But like that, it should work. Except it won't because we can't sign with this. So I remove this. But now it should work. Let's try. Create accounts with seeds. Hello signature. Hello Solana FM. Solana FM. The Solana radio. Sounds like a radio station. FM, frequency modulation. Welcome to Solana FM. Anyway, so we got our signature and look at this. We only have one signer. That's already the main difference, or one of the main, well, can argue about that, but that's definitely a major difference, that we don't need to sign with another account, but we just create account with seeds. Now I'm interested. The discriminator of this instruction is 3. Yes, it is a different instruction, an entirely different instruction. It's create accounts with seeds and not create account, because create account was 0. Yeah, so anyway, we put the discriminator, we put the seeds, or the seed, which is a string. It passes that nicely. We can also have a look at it not so nicely here or here, but yeah, having it pretty is pretty. And the lamperts are the same, of course. The space is the same, of course, because we created with the same number of bytes. And it also put it as the owner. Wonderful. And what account did we create? This one, the DT4, which pretty much looks the same as our previous accounts, with the one exception that it is not on curve, because somehow that account got deterministically derived, which is what we do with PDAs. Just that with PDAs, we make it specific that a specific program can sign for it. And here, I don't think that we make it like, I think there's something else going on here. So there are so many things to explore. I don't even know where to start. Maybe with a drink. Check out my fat glass. Where do we start? Maybe with a question to the audience, such that you stay active. What happens if I do the same instruction again? Because the previous one I could execute many times, but what if I do that one again? What's your guess? Did you guess that it's not gonna work? Then you are correct, of course. But what error will we get? You are also correct in that we get the 0x0, of course, because that account already exists. Address already in use. Why? Because it tries to create the same account again because we derive it here and we have the same 3 parameters, and that will obviously give us the exact same account. We only get different accounts here because we always say new key pair, and that always gets us a random key pair. We would have gotten the same error if we would load a key pair here statically. Like if I would have created another private key and then loaded that as key pair and then tried to do it twice, then it would also not work with the same error, right? Because the 0x0, if the account already exists, we can't create it again. Okay, that's that. So let's do something different here then. Of course, as soon as I have a different seed, like seed with double E, then it's a different account. And then it's going to work again. There you go. But that's almost boring, changing just the seed. What if I would change the program ID and assign it to the system program? What's your guess? What happens now? I always like to do that and then also guess myself because I also don't know 100%. But my expectation would be that the simulation will already fail because it's a different program ID here, so it doesn't allow me to assign it to one. So really what's happening, the system program will also do the same thing and derive that account, and if that account doesn't match, then it will just fail the instruction and say, hey, I would have expected a different account here with those seeds. Because remember, the parameters here that we put into the instruction is the discriminator, of course, but then seeds, and that's the same Lampert space owner. So with owner and seed, and actually I'm a bit confused. Oh, here is you give the owner as instruction data. Is that true? You don't give the owner as an account? That's weird. I would have expected, let me check that in Explorer. But yeah, it's true. The program ID is not actually put in as one of the addresses, but just as instruction data here. The owner is actually put in as instruction data. Funny. Okay, but yeah, so with the base, the seed, and the owner, the system program itself has all the information it needs to derive the account address the same way, and then it will basically check if that is the right account. And since we now have different program ID here and here, the simulation will already fail. Is what I expect to happen. And yeah, there we go. Address, does not match derived address, So it does derive the address and it gets this one, and therefore it gives me the 0x5 of the system program. 0x0, 1, 2, 3, 4, 5. Address with seeds mismatch. Provided address does not match address derived from seed. Ooh, that's true. It does not, because we're providing different things here. Okay, fine. So going back to just providing my program ID. I mean, however, I can assign it to the system program. It's not that that's the problem, right? I just would then also need to put the system program ID here. Then it would work again. Then we could create that account. But we don't want that. We want our program ID. And let's play around with the funder. So just to make sure that it's actually the base pubkey that needs to match with, and not the from pubkey, because the from pubkey is just the guy paying for it. So from this account, we put the Lamperts onto this account, same as we did with the create account without the seeds. But this one needs to be the base pubkey. So this can be a different one now, actually. Why not use a random one for now? Random pubkey as my base to check that also works. It does not, because we now need to sign for the base. Aha, interesting. The base also needs to sign, which makes sense because the system program will give that base pubkey some privileges. And we didn't discuss that yet, because that is ultimately what this is really useful for. Not just saving one signer. Let's be honest. I mean, we can pay for one more signer. That's fine, but whatever. Okay, so fine then. We need the base as a key pair, and also provide it as a signer. Then it will work. Yeah, there we go. The FAE is now the account that is created with the create account with seeds. And see here, now we have different ones. Why is that in a different order now? Are you just putting that in a random order? That's annoying, Solana FM. I want that to always be the actual order that you actually put it in the instruction, because otherwise I will get confused and I do wrong things. The correct order should be from address, new address, base address. So account 1, from account 2, the account, and then the base, because the base is signing and that account is writable. So funding account, the account we create, and then the base. Yeah, so that order as we have it here as well. From new address base. Because I imagined earlier it showed that differently. Yeah, here it showed base, created account, and funding in that order. That is confusing, Solana FM, because that order is relevant, even though they are the same, but it's the from address first and the base address after. So don't display it. I don't know why you display it like that, but wait, now here it's correct. Here it's not. Okay, good. So, I mean, that's one thing where I'm like skeptical of Solana FM now, but that's only one tiny thing. Order of account is important, Solana FM. Solana FM, your favorite Solana radio station, gives you accounts in random order. No, please don't. Hello, I have a request. Can you put the accounts in correct order always? Okay, enough of the radio moderator voice. Moving on to learning about Solana again. But that is a relevant point, that you can't just put them in random order. I mean, if you do stuff like that, right? If you use helper functions to create your instructions, then they will do that automatically anyway. But if you were to create the transaction instruction manually and put in the keys, then order really matters to put it in the right order. Because we could do that manually, but not today. I trust that you would figure that out yourself. I don't want to blow up that video because we still have a lot to talk about. Like, what's the point of all of this? Like, why? I mean, okay, we already saw one thing, and that is because we now derive that account, we don't need to sign for it. I mean, now we sign for the base, but I could have just all done it with the funder as I did here. Then I just have one signer instead of two. And in times of base fees being high, saving one signer saves us 5k lamperts. And also a signature in the transaction, which lowers transaction size by 64 bytes. So yeah, if we can avoid it, having to provide another signature, it's probably a good way to do it. And there are extra use cases for it. We saw that in the video about staking, where Solfware did it with the create account with seeds, so they only had to provide the signature of their user account. And other wallets did it with a normal create account, which in that case doesn't make a big difference. But if you have bigger transactions, then saving signers is a good thing. And this is like especially relevant for temporary accounts. Something like where you create an account and in the same instruction you already close it again. Should we do an example on that? I'm gonna blow up that video a lot, but I kind of want to do an example on just to show what I mean. So let's create lots, start with seeds. Create myself a function that will just derive me accounts. And then I shall loop, I don't know, 20 accounts or whatever. We get pubkey and seed from get account, and then we create the instruction like this with pubkey and seed. I create that instruction, I add it to the transaction, and let's see if I can add 24 transactions with creating accounts, if that all fits in one transaction. Let's see. Lots of accounts with seeds. Value of offset is out of range. Oh, so close. So close. So I think the transaction is just a bit too large. Okay, let's just do 2 accounts for one. Okay, that still works. I can do 2. There we go. I provide 2 signatures, one for the base, one for the funder. But I create 2 accounts, both with different addresses. And for those, I don't have to sign. So let's see how many I can create in one transaction. 10. There we get the transaction is too large. Okay, if it's much too much, then we get this with the offset, and then here we get the transaction is too large. Okay, so actually we are not saving so much if we think about it. I mean, we are saving signatures, yes, but therefore what we're not saving is instruction data. And see, that's exactly why it makes sense to put these kind of fields as actual accounts into the transaction and not as instruction data, because if I put them as instruction data, then I need to put the entire thing every time for every instruction as instruction data. So I will have those 32 bytes for every of the instructions in the transaction, which also blows up that transaction. However, if I had it like this in the accounts, then when serializing that transaction, I mean, this is also 32 bytes, of course, but when serializing that transaction, it would just take an index of which account it has here, because it has first all of the static accounts, and then it uses just indices which account it is. So if two instructions use the same account, then it's just 2 bytes plus the 32 bytes for the account versus twice the 32 bytes if it was in instruction data. That's why this implementation here of the system program taking this as instruction data is actually not ideal. But yeah, a nice implementation just for you as a dev. If you build something, if you're using actual pubkeys, use them as addresses here and not as instruction data. So we can't even put in 10 accounts, not even 10 accounts. God damn it, this is crazy. Total that we can put in is like roughly 30 pubkeys fit in here. And we have the pubkey ones. Then we have the seed, which also has a few bytes. And then we also put each time the program ID in the instruction. So that's basically like double or 2.1 times the accounts, so that's like already 25. And then we also have 2 signers, so maybe get rid of the 2 signers by saying that the base is also the funder. It makes the transaction a little bit smaller, so from 1622 to 1526, so that's almost 100 bytes. 8 is just a bit over, so 7 will still work. Except, yeah, one of them is already created. Yeah, that's true. Just use different seeds then. I mean, this is a pretty long one anyway. Save a few more bytes on the seeds here. There we go. We can create 7 accounts in one transaction. So yeah, I take it back. I mean, yes, we save a signature, which is transaction space, but therefore those instructions need more space because essentially they have 2 more accounts. But we do save the signature fee. So we do save the base fee for the signature. And in case that ever becomes like relevantly high, then it makes sense, you know? That's 7 accounts that I can create like this. And just because I'm interested, what would it be without? So if my get account would just return me a new key pair, and we don't do base and pubkey, and we don't do... Away goes this. Then we see how many we can create here. Oh, now we need to also sign for all of those. So we sign with all of those now. Let's see if we can do 7 as well. I don't think so, honestly. I think it's still a little bit bigger if we have to provide the signatures for all of them. Yeah, it's a little bit bigger. Just about, just a little bit bigger, but it is bigger. So here we will only be able to do 6. I mean, yeah, in most cases that won't make much of a difference, but sometimes you're really close with the transaction sizes and then it does make a difference. Plus here we pay much more in transaction fee because we have a bunch of signers. Therefore, we also have higher transaction base fee. Yeah, okay, good. So we also had a look at this difference. So yeah, one clear difference is we need to sign if we create account, whereas create account with seeds, we do not need to sign. But now comes the interesting parts. Now that I created this account with seeds, what can I do with it? I mean, the one thing is, yes, you have that account and it has space allocated and is assigned to a program, you know, as we did it here manually with a transfer allocate assign. Fun fact, we could also do that here. Ah, so many things that I want to do at the same time. Yeah, let's do that here. Why? I mean, why not? Let's do the manual account creation with seeds with a new random base key. So there's a new address that we haven't used before, even if we use the same seed. The new account is now going to be this one, this public key that we just derived here. We transfer to it, and then we allocate this one, and then we assign this one. This now is not going to work though. Why not? What's your guess? Well, because we don't have the signature for it. Oh yeah, I mean, for one, we're trying to provide a signature that we don't even have. And if we don't have that, missing signature for pubkey, the HPSS is the one account that we want to create. So that's what we derive with those seeds. But if we do it the same way as we do it without the seeds, then the system program just thinks, well, you are missing something. And that is a signature. Transfer still works. We can just transfer that without signing. That's fine. But then for the allocation, the system program says, no, you need to sign for this account for me to allow you to allocate. So what we need to do is additionally here, provide the base and the seed. Then that should work. And the same thing with the assign. Also at the assign, we need to sign for this account, and if we can't sign for this account, well, we can provide base, pubkey, and seed. That way we should also manually be able to create that account without actually creating an account, but just transferring manually. Again, it's almost the same as the create account, except it doesn't check if the account already exists. Nope, doesn't work. Signature verification fail. Yeah, if we have a different base, the base needs to provide a signature, of course. If I have a different base than the funder, then it also needs to sign. Yeah. Yeah, now that works. Okay. And there we go. Now we manually did it like that. We first transferred, then we allocate with seed. That's discriminator 9. Is that now a different instruction? It probably is a different instruction as well. So same with create account with seed. Now we have allocate with seed because it takes different input parameters. And that's discriminator 9, whereas before the allocate was 8. So we do 9 instead of 8. And then we do a assign with seed, which is 10 instead of assign, which is 1. Okay, sure. But the point is, I can also do all of those things manually with just transferring and then allocating with seed, assigning with seed, just by providing the seeds and the base pubkey for both of them. So this really is an allocate with seeds and then assign with seeds, just that the Web3.js puts them both into one. For the create account, it did not put them both into one. Here they actually made 2 separate instructions, even though they could have also just done the create account and let you provide those 2 additionally, which, you know, it's the same as with the other ones. I don't know why here we have a separate function on the system program. They're gonna release a new Web3.js anyway, and everything's gonna change, so whatever, not worrying about that. Cool. Do we first want to look at how that is actually derived? I want to quickly, before I forget, look how it is derived. So it's just this to buffer, so twice those 32 bytes, and then also from seed, so the bytes of the string, all of that into one buffer, and then SHA-256 from that buffer. So that's just a hash, public key bytes, and that's public key bytes. Now that means, in my quick analysis, that doesn't actually guarantee that it's off the curve. That was probably just random when we saw it in the beginning. So actually, let's have a look at that. Just to compare here with the create program address, it concats all the seeds, then it concats the previous buffer with the program ID. So the program ID also goes in there. So that's pretty much the same as here. Just that the first seed here is the from public key, then the remaining seeds. And then here it also does buffer from program derived address. Interesting. So it adds something else. I actually didn't know that for PDAs, they add all of those bytes. Wow, I didn't know that. Cool. I thought it's just the program ID and that's it. But no, it's also program derived address in the end. But that works the same, right? It's just a SHA-256 hash of the buffer bytes to get to our public key. but there it's forced to be on curve, which here it's just not. So that it's not on curve, probably when we saw it earlier, was just per coincidence. Okay, so let's check it here. Let's check those accounts. This one is on curve. This one is also on curve. This one is also on curve. This one is also on curve. There seems to be a pattern, but I don't believe it. Number 5, number 6. Number 5 is not on curve. Number 6 is also not on curve. Number 7 is also not on curve. So, okay, so the first ones all were, and then those were not. Random, right? So it doesn't have to be on curve. It's just, this is random. Like if it's on curve or not doesn't mean anything for those accounts. I mean, for the ones that are on curve, there is a private key for it. But so this flag is completely irrelevant. It's just, if it's false, then it can be a PDA. And if it's true, there does exist a private key. But it doesn't mean the private key was ever found. Nobody ever had the private key for this one. I didn't. I just said, hey, this is the address because it's the result from a hash. That's all that is, the result of a hash. Yeah, so cool. So we now also looked at that. So it's derived differently than PDAs, but also kind of similarly. Good. We also looked at that. Wonderful. Where were we though? Yeah, to finally get to what is that really good for? Or what is the point of this base? Maybe start from here. Why this base? I mean, here's the thing, right? We don't provide a signature, and the system program still allows us to create this account because it was derived in a certain way, namely with a base pubkey, a seed, and the program ID. And similarly to with the concept of PDAs, where we provide the seed or the seeds correctly, and then we do the CPI, thereby prove that we can sign for this. It's similar here with the system program, where we are now basically, we're not doing a CPI, but we are creating an instruction on the system program. With knowing those seeds, so the base pubkey plus the seed, that allows us in the future to basically sign with that account at the system program. Okay, hold on, wait, let me step back. Knowing the seed and being able to sign with the base key, if this guy can produce a signature to the system program, whether that's through a PDA from another program with a CPI or with an actual private key signing the transaction, if that guy can produce a signature, so if that guy is a signer when the system program is called, then the system program will accept that as a signature for that account. And that's the cool thing about this create with seeds. So let's maybe have a look at how that works or what that does. Let's use a second seed, assign it not to this, keep it at the system program. So this would now be the same as if we manually did it and not assign, but I do it with a create account with seeds. Okay, same thing. And this time I created the account Ecre, and it's still owned by the system program. Now, can I use my base to sign for that account? Can I do a transfer? Let's see if that would work. I don't know. Yeah, look, transfer also has seeds and base. Haha! Look at that. So as usual, from my new account, which is not the new account anymore, but it's the account that we just created, Lamperts, 1 to 3 Lamperts. I mean, it has a bunch of Lamperts there anyway. Oh, except it needs them for rent. Well, then I take all of them to close the account again, because otherwise I would need to top it up or do something else to make it work. Program ID, well, that is the program ID that the assigned it to, so it must also be the system program, of course, because otherwise that won't work. 2, well, I don't know, I'll just steal it myself. Seed, of course. Okay, now that won't work because, well, I mean, if I pay with a funder, yeah, why not? Just set the fee payer to the funder, such that I don't need to transfer Lamperts to the base account first. Okay, and let's see if that works. Let's transfer with seed. I've never done that before. Transaction references a signature that is unnecessary. Only the fee payer and instruction signer's account should sign the transaction. Well, the funder is the fee payer, so they should definitely sign. The base, did I not provide the base here? Hold on. Yeah, I'm missing the base pubkey here. Haha, oops. And if I don't do that, then it would just do a normal transfer. So that's a different instruction on the system program. Let's say I just did this. That's a normal transfer. That's a normal system program transfer. And that's what it found for now because I forgot the base key, pubkey. But if I put in the base pubkey here, then it will also require the signature of that. And then I can provide the signature here and it will not complain. But it will complain later that, of course, it can't do a transfer of an account that already has data. Okay, fine. I could, however, just using the base key now assign that account to someone or whatever. But I do want to make this work to prove to you that I can transfer just by providing the base. In the creation step, set the space to 0. So create that account. We go, we create that account, and the lamperts are gonna be different now. Let's check it out. It's not gonna be 0 because even an account with 0 bytes, if it exists, needs that amount of sol. So that's fewer lamperts, but I'm gonna remove all of them from the account with a transfer. Let's see if I, now that it doesn't have data, can transfer that out. And yes, that works. Look at that. I can now, just by signing with the base and have a separate fee payer, but don't worry about that, we send from that account to my account with the system program, and that instruction was a transfer with seeds, which also will have a different discriminator, which is 11 and not 2. Haha, funny. I like it. That looks like something is wrongly decoded because that doesn't seem right. Hold on. Let's double check with the real Explorer where we see, I mean, I still just love that. We see that this account was funded and this account was closed and it now has 0. And if we go there now, we will see that this account doesn't exist anymore. It's closed now. Even though we couldn't sign with that account, or we didn't sign with that account, we can't, well, but the system program still allowed us to close that and transfer the lamperts out because we provided the signature of the base pubkey that the other account was derived from. So it's similar to PDAs, where basically this address is in a way the program that then like the authority over that account. And yeah, that's fun. But yeah, what was I checking here? Yeah, this one decodes it correctly. The seed is seed 3 and the owner is the system program. Yeah, so I mean, I kind of like how Solana FM shows many things, but they apparently still have bugs for some. I mean, I could look at the raw stuff and decode it myself, or even in the but even here, the JSON, that's wrong. It's just plain wrong what you decode here. Just saying. So not perfect, but I mean, looking good most of the time. I still have some issues with Solana FM, your favorite Solana radio. It looks nice, and for many things it gives me nice displays. But then if it shows wrong stuff, as if the Explorer doesn't show wrong stuff sometimes. No, it just shows outdated stuff sometimes. But anyway, yeah, let's not do a Explorer comparison here. I'm just realizing that not all things are correctly decoded, which is the job of an Explorer, damn it. And who really needs those to be decoded? Like, who really works with them? I don't know. I do now. Cool, but ignoring that that's wrong, what else can we do? Right? Basically, anything that we do with the system program where we need a signature, we can now sign basically just with a base pubkey for another account. What other instructions does the system program have? Again, allocate and assign. We already saw that we can do that with the seeds. Create nonce account. We could, for instance, also create a nonce account by providing the seed and the base. We don't need the program. Why? Well, because the program will be obvious, right? System program does the nonce accounts. The system program does the advanced nonce as well. Advanced nonce will, guess what? Have the nonce pubkey and the authorized pubkey, and the authorized pubkey, that could potentially be the base key then. Should we try it? Let's see if we can create a nonce account. Yes, we can. It's basically just a create account with seed and then an initialize nonce account. That's what we need the signature for, to allocate data. And then once it has the data, creates the nonce and the authority address, in fact. But yeah, oh yeah, and that's how it doesn't require the signature, because it has the authority address. Here, the authority is now the base. So now we just need the signature of that one anyway. So at that point, it has become useless that that specific account is derived in that way, because there's a field in the nonce account with the authority address, and then it's the account that we set as the authority. We could have, of course, also set a different authority though. So that's the authority that we assign, and that's the authority that we currently have. So that's how that works, right? When we create the nonce account, we provide the base pubkey that we need to sign with, and then we can set the authorities to some other pubkey or keep it ourselves. But then once it's written in there, then those 32 bytes are written into the nonce account as the authority, and then it works as with any other normal authority. We just require that authority to then do stuff with it, like transfer lamperts around. So yeah, essentially with creating an account with seeds, we can create ourselves also a system program account where we can then do transfers without having the private key for the account itself, but providing the private key of the base account, which can then sign for all of those accounts. That's how we can, with one key, sign for a lot of other accounts with the system program. And yes, only with the system program. This is only a system program specific thing. For other programs, you can't provide signatures like that because they don't implement that. It might be a pretty niche use case, but it could be potentially helpful for some things. And which things they are, I will potentially figure out at some point in my Solana development journey. At that point, I'm happy with knowing how all of that works. And then later my brain will come up with nice solutions for things. Because this is what we're doing here. We're building a toolbox of, Solana primitives that we can use to build our Solana programs. We have the regular accounts, the PDAs, and the accounts that we created with seeds, and we can make cool stuff with it. So I think it's cool learning about these things. But also, I think it's cool to not have videos that are too long, so I'm gonna end it here today. I think we learned enough. I'm happy with what I learned. I mean, that video got way longer than I thought. I thought it would just be me saying, hey, this is how you create an account with seeds. You just put in the base key and the seed, and that's gonna be it. But no, 3 hours later, I'm still talking. But it was fun. It's always fun learning about Solana, especially the base stuff, like the primitives, like the core, the Solana core stuff with the system program stuff. The system program is so, central for Solana development that you really want to know what it actually does. And in detail, like what all of the instructions do and all of the parameters. And yes, I've been developing in Solana quite a long time without ever learning what all of those things do, but better late than never, right? And really, you just need to learn it when you need it. But also, as I said, if you know it, then you can better design your programs and come up with better solutions, because you know that that stuff is possible. It is possible that you just have one private key that can essentially sign for many accounts, because it just signs for itself, but then other programs treat it as if that other account signed. Thank you for watching this video. I enjoyed making it, and I enjoy making more videos. So make sure you subscribe, you like this video, and you watch others as well. Yeah, because I got some fun videos where you can learn Solana development, and you will be back for the next one, I'm sure. Till then, bye-bye. And this was Solandy's Solana tutorial. Tune in next time where we'll bring you another interesting episode. Only here at Solana FM, your favorite Solana radio. I should become a radio moderator. Or maybe not.